Yeah, recording started. Yeah, go ahead. Yeah, am I audible, Shashank?
Yeah, you are audible. Actually, yeah, I'm
Oh,
sharing this.
okay.
This is okay. So our first question has what is that? Arithmetic slices, subsequence two, and a sequence of numbers is called arithmetics if it consists of at least three elements, and if the difference between any two consecutive elements is same, right? For example, these arithmetic sequences are 1 3 5 7 9. So like difference between these two is two. Difference between these two. I mean, overall, it's arithmetic series with a difference of two. Arithmetic series with a difference of zero. And this is like this is if you take the difference of these two, it will be four. Then this will also be four, and this will also be four. But this is not because uneven difference is there. Yeah. So we have to find out how many such these what do you say uh, such AP sequences are possible in this given array.
Okay, so how many subsequences are possible, and that is what the number of count of the number of subsequences we need to return.
Exactly. Yes.
Mhm.
Yeah. Is the input sorted?
No, that is what you have to check, right? Whether it,
Okay, okay. It's a subsequence, right? We cannot
Subsequence,
touch
yeah.
the. Yeah. Okay.
Mhm.
Sorry.
But order will be important, so it might be sorted in some other way, right? Yeah,
Yeah. So yeah, any AP subsequence would be sorted in itself, right?
yeah.
It has to
yeah,
be.
yeah.
Mhm.
Hmm.
Is it? This
Okay.
is not. This is a AP sequence. It's not sorted.
Acha, okay.
It's sorted.
It
Like
is
this.
sorted,
So
right? Yeah,
negative
Yeah.
common difference, right?
yeah. In a descending order, you can say.
Yeah.
Yeah.
It's
Mhm.
bigger to smaller. Yeah.
Okay. So now he is talking about us. If the sequence at least should be of a size
Two,
3, right?
three length size, right? Or two,
Yeah,
three.
3 and above.
Okay.
Hmm.
So brute force like generate all the possible subsequences of size three and just check if the difference between adjacent element is same.
Okay, yeah,
Kind of, right?
right, right. So you create all subsequences, and then you check if they have a difference, same difference, and then you add to your resultant array. Hmm. Yeah, that makes
Yeah.
sense.
Yeah.
And that time complexity will be
And Q
okay.
n square for generating subarrays and not subarray,
No, no.
sorry, subsequence. Sorry, I made a mistake here. Two
It
raised
will be
to the power
exponential almost, right?
n.
No?
Yeah. Two raised to the power n into two raised to power n, right?
Right. Yeah. Because we'll have an recursion to generate that, and we won't be able to use any memoization techniques there, right?
Yeah. No, memoization we can use, but backtracking like this way. I'll take first one, right? So with one, what is the possible sequences? Either I can go to three or I can go to minus two.
Mhm.
I mean, if it has to be in AP. But minus two is not in my array, then I'll proceed for three. Now, if I have three, so but how come I know that what is that difference, right?
No, but brute force is not that. No, we take the existing element in the array and then take the difference.
Yeah. But he's trying to check the reverse way, it seems, right? Okay.
Yeah, but how will I know the difference in advance?
Yeah,
Yeah,
you can find out
Yeah.
because
How will you get?
yeah, because if you have a difference already, okay, then you add that difference to your starting element in the in your sequence, and see if the whatever you have added that value you have a similar element in your subsequence, right?
But when you are here, how will you know the difference?
But you will at least have two values to have a difference, correct? So you'll go to
Oh,
three also to find a difference.
First two numbers you take. And
Yeah. So 3 minus 1 will be 2 difference. So you'll add 2 either to 1, but you'll come back to 3 again. But you'll add, if you add 2 to 3, you can go and see 5 is already there.
Is brute force approach not like we apply a for loop and keep taking the difference as the numbers come? So first we'll take 1 and 3, take the difference, uh, and then take 3 and 5, take the difference, and that difference will keep comparing whether it's coming same in the loop.
Yes, yes, yeah. So
that's
that is
what.
what we'll have to do to validate if it's a sequence, right?
Yeah. All the possible. That is what then C is generating all the possible subarrays using two for loops, not the subsequence, right?
Mm,
Much.
You can
Okay,
use a
so can you come again, Dipali? What was your approach?
So we'll just apply like for loop and add a recursion within that. So yeah, like for if I take like two for loops, then it will be each number with each other number. So that will be a sub array. It won't be in a particular sequence.
Mm, Okay, so let's take an example. Let's say this is the array 1, 3, 5, 7, 9. Okay, so you take your first element as 1, and in the second element you are at 5. Okay, so you have a common difference of 5 minus 1 equal to 4. So now are you saying that you look for the third element and thereafter?
Yeah.
Okay,
Fine.
so first you'll find all the subsequences which have the first element as 1 and the second as 5 of length 3. Then you keep on going till the maximum length.
Yeah, but
Is it?
that is not the question. Yeah. It's a sequence. So if I can't miss 3, it has to be 1, 3, and 5, 3 of the
Yeah.
numbers.
No, you
Yeah.
can miss it. It's a subsequence.
No, but how will you miss it? If you do it by for loop, you cannot miss it, right? Then
Yeah, that's then it will become a subarray, right?
yeah, that is what I was coming to. Yeah.
I thought it's not, we cannot miss it. Can you show the output, sample output in the examples?
Yeah, sure. No, subsequence itself, and it's not mandatory to miss, but you can
2, 4,
see.
6, 4, 6,
But
8.
yeah, you have to keep that option on, right? You have to
Mm.
take care of non-contiguous also. So there's
Yeah,
another
some
question which is the same, but there it's asking number of substrings, subarrays.
one you are talking.
Yeah, yeah.
Okay.
Yeah, okay. Yeah, so that if you have to really find the subsequences, you will have to use a recursion, right?
Subsequence is non-contiguous and sub-arrays is contiguous.
No, subsequence can be contiguous also, but it is a general, like it is contiguous plus non-contiguous both.
The order is
Subsequence.
important. It has to remain in the order of the.
Difference between sub-array and subsequence.
You can
So
skip
yeah,
some elements in subsequence.
Okay,
But
so if you look at 468, right? 468, and if you compare the input array, or not 468, if you take 6, 8, 10, no, not even that. Is there something
Yeah.
below? If you go down,
Two
I
six.
think the last one. 2, 6, 10, yeah.
Yeah.
Yeah. That if you see 2, 6, 10, and if you see the input array, so 2 and 6 are not close to each other, right? And 6 and 10 is also not. So, but it's still a subsequence because it is maintaining the order with the input sequence also, right? So
Yeah.
6 always comes after 2 and 10 also always comes after 6.
okay.
Yeah.
yeah. So Dipali, do you see a subarray also in this explanation somewhere?
Sub-array. This 2, 4, 6, 4, 6, 8 can be sub-arrays.
Right. Yeah.
Mm.
So yeah, a subsequence is also a subarray.
Yeah.
Subarray.
It can be anything as long as the order is preserved.
Okay.
So, okay, so then what is the best way to do or a
Then
better way to do?
Okay.
DP way.
So
Go.
yeah. So what I am thinking of is like a LIS kind of thing. Okay. So at every index, like every number, I keep track of the number and the subsequences ending at that particular number with some common difference.
Okay.
Okay, so I might not be able to annotate because I'm logged in through my phone. So let's say I'm at 6. Okay, then let's say I have some subsequences which end at 6, and I also have the common difference. Okay, so let's say I have n number of subsequences which end at 6 and have the common difference 2. Okay, so now when I go back, I go to 4, I see that there is the common difference is 2. Okay, so whatever subsequences I had at 4 which ended at 4 and which had the common difference 2, I can easily append 6 to all of them. Right?
Yeah,
Correct.
makes sense.
So something like this. I mean, we have to keep track of the common difference also, and for that common difference, how many subsequences I have which end at my particular number, and then just go back, start from the beginning, and yeah, keep the common difference for a particular comparison I and j, and see like how many elements you have for the left one, and then add the number
to the number. Yeah. So what base is, I mean, he's telling, like, I'm just annotating what he's saying. So at least that DP will have at least 2 elements, right? Then only you can get the difference. So what he's saying, one subsequence will be 2 and 4. This is one possible. And what is the difference? Difference of these two is 2. And we have obtained one such subsequence of that size, right? At this is one such. Now, when you go for 6, you check the difference 6 with 2. 6 minus 2 will be 4, right? But there is nothing in this one. So one arithmetic sequence could be 2, 6. But now when you check with 6 and 4, there is a difference of 2, right? And you already have uh, arithmetic sequence of difference 2. So your next sequence can be what? 2, 4, and 6.
Yeah.
That means 2, 2 you have. That means a difference of 2 you have in this arithmetic sequence with a size of 3. It's 3, right? No, this
No, why
size is
3? 2 only, right?
2 only, yeah. Not 3, sorry. And now again, when you come to 8, you check 8 minus 2, 6, but you don't have anything. So this could be one, what you say, arithmetic sequence. And now 8 minus 4 is what? Uh, difference is 4, but you don't have, I mean, here the difference is 2. So this could be 1, 4, and 8. And now 8 minus 6 is 2. And this is the sequence which is going with 2. So 1 could be 2, 4, 6, 8. So this will be like you are getting, I mean, this AP is of difference is of 2, and you update one more, 3 it will become. So this is the max you have seen till now. I mean, if they ask us to math, but here they are asking us to generate all the possible. So at this point of time, you have all this possible.
You can have also from 8 to 4. The
8.
difference is 4, right?
8 and 4. Yeah, 8 and 4 you
8
can
and
have
4,
that.
the difference is 4. So you already have that 4 and 8. So you can also append that 2, 2, 4.
2, 4, 8. Okay, yeah. No, but
No, how?
2, 4 you can't. 2, 4, 8 can't be, because the difference here is 4.
248 will not be possible because the
Right,
difference is different.
Yeah.
Now, if this is 10, then 10 minus 2. So this is one such sequence you can have. And 10 minus 4 is what? 6. And you have no such sequence with 6. So this is a separate one, 4 and 10. And then 6 and 10 is 4. And yeah, we have this 4, right? So 2, 6, and 10 could be one such possible. And 10 minus 8 is 2. And this is what you say. 2 difference we have already, right? So till now here 3 we have obtained, and 1 when you add 10, then you can have 4. I mean, the length, or like not the length, like these many sets you can have. This is 1, 2, 3, and then here we should have 4. Maintaining the count kind of
Yeah.
corresponding.
So you are saying that at each and every 2, 4, 6, 8, you will have a differences. Okay. So there will be a difference in the 4. You will have only a difference of 2 because you are
Yeah.
actually taking a difference with the previous one. But in later on, you can have differences more than 2 also. So then you are
Exactly. Yeah.
bucketizing on based on the differences, correct?
Mhm.
Okay.
Yeah.
Okay.
So we can keep a hash map of the key as the difference, and we only need the number, right?
Yes,
But
Not the exact.
it's just the number.
yeah.
Okay.
This is a bottom up. I don't know, top down. Like top down also will go like this only. With you can memorize it, right? When you see this repeating already in that, you can just update the value there itself. I mean, new key you'll have to generate and the value, right?
Yeah. So the top down
Yeah, you
would
can go
be,
from behind. You can start from the last element and then move towards the left. And when you hit the base case, like
Okay.
when you hit 2, then you would start your subsequence, like
Mm,
your answer part. Then you come to
exactly.
4, then you use the answer for 2. Yeah, so basically start from behind.
yeah.
Yeah.
Yeah. So for the top down, you can have a recursion with a for loop, right? And then
Hmm.
you can keep on going, and then you memorize that. Yeah. I think that might work.
Should work. Yeah.
Yeah. But again, you'll have to keep checking you'll have to validate the subsequence at your end every time.
Yeah. So there also you'll have to use map, I think, because you need to cache it also, right? That till this point I have obtained arithmetic sequence of
Yeah, the map,
different.
you mean to say the difference? I don't know, because I was thinking like you do the normal recursion, the way you form all the different subsequence, right? And then you go and validate that at the end, and then it will go in exponential for sure if you don't use memoization. So if you can find a way to use memoization, then it will be at least a optimal solution. Not a very good solution, but at least it will pass the lead code.
The
I'm just thinking loud. I didn't implement it, but think it might be possible. But
I
the
think
difference.
map would help.
Mhm.
Yeah, please go on.
to restore the previous state map will help. I mean that
Yeah,
caching.
if you want to actually maintain all the differences and all those things, then bottom up is the better solution. At least you can visualize it, right? Hmm. Yeah, sorry, actually, yeah, go ahead.
No, I'm just thinking. Yeah,
Mhm.
just a minute.
No problem. So if we have to do a bottom up approach, uh, okay, there was one which is given in the solution also, but it is slightly okay to follow. I don't know how you guys found out about that. Yeah, but there might be slightly better ways of doing it also. It's
You
not
want
so easy to find out, right?
exactly, yeah. It's
Mhm.
late.
But the way you are explaining, if you always find out the differences with the previous one,
Hmm.
okay, and every time if we find a difference, and at a particular index wherever we are, like if we start our for loop at the top level and we say that is being iterated by I, okay, then we come inside and we have a j, a nested for loop which will actually follow till that I. So that second one actually is trying to follow with the subsequence, and you can find the differences at that time, right? So you can always say where your j is, okay, and the difference will be your buckets for that particular j. And then you can keep on adding those number of subsequence you have encountered till now with the j pointer, correct?
Current index, yeah. It's LIS. I mean
Exactly
following.
what Harshit was saying. So LIS way, yeah. So that becomes easy to visualize as well as understand, right?
Related. Yeah, yeah,
Mhm.
yeah. So just this is the yeah. This I was just going through the discussion and
Mhm.
just what. So what your DPIJ will say, it will store the number of arithmetic slices whose constant difference is j, which is ending at I. It's just what you said just now, right?
Mhm.
So this is what the code is. I mean, I've created an array for every item, for every element in your
This is
uh,
the
God.
whatever we explained. This much is the code. I'm just surprised.
You know, they have implemented it very precisely. That's why, like, implementation is like that, but this is like,
Yeah.
yeah, that way. Yeah. So for every what do you say? For every element in the array, you are creating a dictionary for it, right? And this is again the, I mean, going through from, if you are at ith index, we'll again start from that zero index to the ith index, right?
Mm-hmm.
Top one is for going through the entire length of the array, and for every ith length, ith current index, you go from beginning to this point. And dp of ij is the difference. If you find the difference is same, then just you increase in that, right?
Mm-hmm.
Like 2 4, and again if you find 2 4 6, you just increase the count, something like that. And if difference is already present in your dp, right? Mm-hmm. Oh,
Yeah,
this
that
is
is correct.
no. So why this if ai minus aj is in dp?
Yeah. So if you
So
find, if you
this
already have
tells
a
that,
difference.
yeah. So any
Then
subsequences ending at j, if there is any difference of ai minus aj in that
you will,
subsequence, you are
oh,
reusing that on line number
oh.
10.
So this is for increasing the frequency, and this is for getting the exact sequence.
No, no, no. This is for uh, subsequences with length 2, I think,
Yeah, the
on
previous
line
one, right?
number 8.
Yeah. Because from line number 9, you are iterating in the J pointer, correct? And for line number 8, you are actually storing whatever you had a difference the prior one with I. Okay. So at least first you have to add that. And
Yeah.
then you'll have still some more subsequence which you have already calculated before, right? So that is what
Yeah.
that will be in the J.
Yeah.
Okay. Yeah, for that. Yeah, and just we are adding the, picking the value and just adding it to the total, right? So we have to give the count only, right? Okay, yeah. So we are just picking from that index the value and just appending to our total and return the total.
Okay, but I thought the DP array at the end will be having the total, right?
So DP of total, you are saying?
We because he is actually explicitly doing the total here, and why
No,
that
but
has to be.
we are nowhere caching total in our array at any point, right?
Okay, okay. So now I got.
Yeah.
So line number 8 actually, it will be also one for the subsequence which are weak, the way he was saying, right? So that is what this 8 line stands for, and therefore he is not taking the DP of whatever that last value will be. He's not returning, but he's only adding the total over here in the if loop, if condition, right, on line level. Because on line 11, he's sure that all the subsequents are not weak. Okay.
Weak identity, what is that?
So weak in the sense like if you have a subsequence of only two elements, you can always form a
Yeah.
subsequence, right?
Actually, if we have a matrix made, that will make it more clear. Like how we are updating this in the line number 10,
Yeah. Yeah.
what
Okay.
we are incrementing it with.
Right. Yeah. We have to make that. But see, did you understand Shashank on the line number 8? So that is
Can you
the
annotate?
main thing.
Can you annotate Santosh, like which? I mean, I'm confused here, like this and
Yeah, that is no, this is exactly what has to be done, right? So if you are on this line number 8, so when you are actually at 2, okay, and 2 and
Mhm.
4, so this 2 and 4 can form a subsequence, right?
Yeah.
Okay. Yeah.
So that will be the first value which you will update, but that is not a part of our answer. Our part of our answer is 2 4 6 at least. So but we need this condition, okay, when we are actually appending anything here. So when we come here, okay, and when you come in this if condition here, right? So we check
Okay.
if the difference, okay, in the previous dp of j is the same as what we are looking for. It means we have already updated this condition somewhere else, and therefore this will come over here in this dp when you are actually adding it on this line. So
That
in
is for
this
the
kind,
six, when you're appending 6 to 2 4, right?
correct,
In number.
exactly.
Okay,
Yeah.
okay, got it.
So when you come for 6, then only you will be coming in this if condition, and then you will be able to update that. And therefore, your total will be only for these cases and not for year, not for the outside ones. So this is the weak subsequence, and this is the complete subsequence. Therefore, he's taking a total over here.
Got it. Yeah. Yeah, it looks short, but I mean, little bit confusing. It was that long. You have made it clear. Yeah.
But okay, if we have to actually completely go through the flow, right? So 2, 4, 6, 8. So we'll have to exactly follow what is written in the code. Then it will be clear.
Let's do dry run. I think that will make sense, right?
Yeah, like I'm not, it will be like for me at least, it's not easy to visualize how that matrix is formed and how the values are updated. So even when we are discussing it, so if we make a matrix and see how the values are updated in each index, that will make it easier to understand.
Mhm. Okay. So you want to do that, Shashank?
Okay, let me. You can help me. Like I am. Okay, you can go ahead. Go ahead. Yeah, I think because I'll
Yeah,
be.
we'll help you. You can start.
Yeah, good, Shashank.
Yeah, I mean, I'll draw the same table only. Then this is like 1D array, and for every element you have a hash map, right?
Hmm.
Yeah. So 2, 4, 6. At least let's say take only 2, 4, 6, 8, maybe. Yeah.
6, 8, okay. Now, first line is what? DP of 0, right?
Okay. Now if you iterate from the I, okay, so
Hmm.
you're going for the first I will be 2. So your
You will not.
7 will be nothing, right? So your 2
Yeah.
column will be blank. Correct.
That will be a empty. Yeah.
Yeah. So then you come to your 4. Now you can actually do, so you can find a difference, okay, in this 2, 4, which will be 2. So that will be a bucket of 2. And there you can store, so you will at least store 1. Okay. So now you'll have, like you have a single one array, right? You should have a 2D also. And the rows will actually represent the differences. Correct. So difference
Yeah.
1, then difference 2, difference 3, difference 4, something like that you will have to make.
Yeah.
Okay.
You can mark it.
Yeah.
I
So
think. Yeah.
so what you do is you store the common difference and then the number. So below 4,
Mhm.
you just below 4.
Okay, I'll just mark the differences first. Yeah.
Okay.
Okay, so for below 4, so for the first row, we don't have anything, I think, right? My bad, I'm so bad here.
Yeah, no problem.
And then, so this guy. So below 4, when you have a difference of 2, you can mark 1 here, right?
Yeah.
Yeah,
Yeah.
I have
this
a
one.
question here. So in the DP array, we are storing a dictionary for each element.
Yes. Yeah.
There is
Yeah. Yeah.
That's the
Yeah. It's
key.
the reverse here. Yeah.
So there is an empty. So these all. This is a list of empty dictionaries. So if there are like 5 elements, it will be like 5 dictionaries that we save in the list.
For every element. Yeah.
Okay.
Yeah.
All these square
Yeah.
boxes will contain a dict. You
Yeah.
can say.
So dictionary is something like a, yeah,
And
Yeah.
then
And also to be clear, like here we are taking the elements as the columns. In the code, it's on the rows.
right.
Yeah. So just for Dipali's sake,
Yeah.
and
So we did it the
the
other way.
difference is on the. It's the other way.
Right.
Yeah.
Yeah.
and what's the key value pair for those dictionaries that we store?
One will be your what is the common difference, and the other is like how what is the length of your. I mean, how many such sequence have you obtained?
Yeah. Not the length.
Okay. So
Not the
when,
length.
yeah. Now when you come to 6, okay, we still have a difference of 2. Correct. So when we
Okay.
come to 6 and then we have a difference of 2. So here on this line, on line number 11, where you take the j, okay, for the 4 you have at least a value 1, right? So you'll have to fill this cell now, right? The 6 which has a difference of 2. So you can always
But
go back.
before that, Satosh, sorry to interrupt. You'll also add uh, 1 for a difference 4, right? You have 2,6.
2,6. You mean to see here, right?
Yeah. So for a difference of 4, yeah.
Okay. So difference of
So
2 to 6, 4, I'll add 1. Yeah, that is true. But then when
yeah.
I come, in this case, I don't have anything over here. This is 0, right? So I won't add 1 here. But then when I come to 4, when my j goes to 4, so I have at least 1 over here. Okay. And then
Yeah.
this one actually I can add to my dpi of where the difference for this dp6 here. Okay, now I can add 1 over here, correct?
Yeah. But before that also, like doing it for 4, you'll again do the same thing for 4 on line number 8. You will do +1 for common difference 2.
For on the fourth, you mean to say this difference?
So you are at 6, right?
Mm-hmm.
Yeah, here only. So you will just make it +1, 1 + 1.
But this we already did 1, right? So we can have
So you
only
did this
one
for,
value.
okay, this is 2. I'm sorry.
Yeah, because you won't
Yeah.
have a difference for 4 in this case, right?
Yeah, you're right.
Yeah.
You're right.
So we have this 1 over here, and this one actually will be a part of our total, right?
Yeah.
So these are all just the building blocks for the next ones.
Yeah. Yeah.
So then when we come to 8, in that case, then we again start from the first. So from 2 to 8 is the difference will be 6. And so if we had another row which was 6, then we will mark that as 1. Okay, so
Yeah.
we don't have it, that's fine. We just ignore it for now. But then we come to 4. Okay, so 4 and 8, we have a difference of 4 over here, correct? So this
Yeah.
one. So in this case, then we can update 1, and that will be a part of our solution, uh, which will be, no, it won't be a part
No,
of our
not a part.
solution, not a part
Yeah.
of solution. Yeah, sorry. So, but at least we will have 1 over here, correct?
Yeah.
Okay,
There
so
one. Oh, 8 minus 4. Okay. Yeah.
8 minus 4, when I come for that I'll have 1 here, but I cannot add that over in this case. But then now when I come to 6, okay, 6 and 8, we have a difference of 2 here, right? So we already have 1 over here.
Plus
Okay,
1.
so 1 plus 1 will be 2 in this case, and this will also be a part of our solution.
So
Yes, so you will have, I think, 1, 2 and 4 such cases, correct?
yeah.
1 plus 1 2, and 2 plus 2 will be 4. So if we see 2 4 6 will be 1, okay, and 4 6 8 will be another one, and then we can have what else?
4 6 8.
4 6 8 3. But then how is the fourth one coming?
No,
So
we
are
haven't
we taking 10
taken
also?
No, we are not taking 10.
No,
So it's fine.
no.
Then it is right, no? Then we'll have 2 only. We have one
Yeah.
ending at 6,
One.
that is 2 4 6, and we have one ending at
8.
8, which is 2 4 6 8. But we also have 4 6
Yeah.
8, right?
And
Yeah.
6 8 also.
Yeah, we have
Okay.
2 4 6 8 also, right? Yeah.
Mhm.
So we have 2 4 6 1, and 4 6 8 is 2, correct? And then 2 4 6 8, and then yeah, these are the only three what we can have.
Yeah.
Right.
No.
Yeah.
Okay. No, one is full.
So this won't be there, I think. Yeah, this is not the right one, right? Yeah.
Yeah.
So it is 1 plus 2. Yeah, we have
So,
3 sequences of. Yeah, go ahead.
no, I'm saying table is going this way, right? Like this way.
It's not. It will be filled at many places. There is nothing like a diagonal way. It depends on
Or
the
random.
Okay, so
differences.
2 4.
All
So we're not getting
previous.
right answer, right? We are getting only 2.
Yeah, actually,
No,
here
3
it
are
should
ready.
be 2. Here it should be 2. Actually, this answer, and here it should be only 1, I think.
I think 1 1 2 it should have been, and here it should have been 3, right?
No, why should it be 2 at for 6?
Because because for 6 the difference is 2, right? And we already had a sequence 2 comma 4 is 1. So when you added 6, it should have been 2. To this you could have added 1, right? And now you
No,
got
no.
a 8.
If you see at 6, it can be only one sequence, 2, 4, 6. So if you come to 8, you can have a sequence of 2, 4, 6 and 4, 6, 8.
Wait, actually we did get the answer, right?
Yeah.
There is a two sequences of size 2 and one sequence of 4. So if we add that, 2 plus 1, that will give us 3.
Mm-hmm. Shashank, what are you doing? Okay.
Okay. I thought drawing was creating a disturbance.
We already
No.
the last cell's output and add. So this
Yeah.
2 1 will give us 3.
Yeah. So we will have 2, 4, 6 will be one only entry for difference 2. But at 8, for when the differences are 2, we will have two entries, right? One will be for 468 and other will be for 2468.
So how do you keep track of 468?
Yeah, 468 because when we come on, we will also have one previous one, right? When you had a difference of 2, okay, which you added in your total, that also will be added for the 8 one,
So
because you have 246 and you have completed initially. When you are here, you are just putting 1. Okay, I'm just marking it with double circles. So this is 1, but when you come to 246, okay, so you will take this 1 and then you will mark that as 1, but that will be your answer, correct? So if I mark this with 3 circles, so this is our answer, right? But then when you come to 8 with difference 2, so you are going to add this one, right? So you are going to add this one, so that will be also a part of your answer, correct? But also you will be adding, okay, you need to add one more 2, 4, 6, 8, right?
Somewhere I think we are.
Yes, stop. Yeah. Okay.
So we are not using the table always, right? You are always also checking the length.
We
I
did
mean
get
whether
the
it's
right
valid or
answer. So if we look at the two row, second row, with the like for the subsequence ending in 6, we have count 1, and for the subsequence ending in 8, we have count 2. So we when we add these two numbers, we'll get 3.
that
That's
is
the right answer.
Yeah,
no,
because
but
we are going from 4 and 6 also, right? For 8. Yeah.
No, but ending, we have to see where it ends. So
Yeah.
as we look, when we see 6 as an ending, the count is 1. And for 8 ending, we get count 2. So we have to add these two numbers to get
Right.
the final output.
So you'll have to add everything in this 4 and everything in this 6 when you are working on 8, correct?
Oh.
Yeah.
yeah.
So this one and this one, so these two will be adding it here, right? So this, there are too much of clutter here now, right? Okay. Yeah.
That's why I was trying to
So
remove.
if you remove the whole thing, then we can actually do it again. Yeah. Okay.
Okay. Shall I remove everything?
Yeah, that's fine, right? Okay. Yeah. Remove it quickly. We'll make it. Okay. So if we have 2, 4, 6, right? 2, 4, 6, 8, and we just focus on the difference 2 now. We don't do all. Okay. So when we are doing the difference one, the call will be, it will be empty. So when we come to difference 4, here you will have 1, right? And then when we come here, okay, so we also have 1, but this will be a part of our answer, correct? So but then
Because
when, sorry,
because length 3 we have covered. That's why you are considering it as a part of answer.
yes, so when we are at 8, okay, so we are actually looking for the 2 first. It is 0, so that is not our part of our answer. But when we come to 4, we find 1 over here, okay, so that becomes a part of our answer if we add 8. Okay, because 4, 6, 8 will be one of our sequence, right? So 8, I'm not adding 1 now because I'll be adding one more if I come to 6 also. So 1 plus 1 will be 2, right?
no, Santosh, 1 minute. Why are we adding for 4? when we are at 8?
So when we are at 8, because the difference, so difference, we are
248
still looking at 2 difference, right? So we are not focusing on the 4 difference now. Okay,
but
so when
two
we
four
are at 2 differences of 4, we still have 1.
but 248
Okay.
is not a sequence, right? So why we are taking care of? Mm,
Yeah, that makes sense too. Yeah. So because then we come to 6, if we add that, right? So, hmm. So in this case, then we should have one more sequence, right? See, one is okay. So this is a part of 246, which is the 3 base sequence. But in this case, we'll have a sequence of 4 to 6 also. So that will also have one count over here, right? So, but that will not be a part of our answer. So here in this 246, our differences of 2 with weak subsequences will be 2, right? But the complete answer will be only 1. Okay, so that this one and this one, if we add, then we can make it a because this one is a part of 3 subsequence, strong subsequence, right? And this one is a part of a weak subsequence, which is 4 and 6, correct? So
Right.
therefore, in this 8, we will have a this weak subsequence of 4 6 will become a strong subsequence in 4 6 8, right? So that will be one
Correct.
answer. And then we will have this storm subsequence, which was 246 in the 6 to difference 2, and then it will be a subsequence of size 4, which is 2468
246.
in here. So these
Yeah.
will be 2. So therefore this value will be 2 over here, and this is also our answer. So 1 plus these 2 will be 3, right?
Yeah.
Okay.
So we'll have to keep track of length also, like by marking whether it's a valid or not.
No,
Uh,
I don't think so.
no.
So if it is
Then
already,
how do you consider this is the invalid one, this is a valid one?
So that is
Three.
what the weak subsequence is coming in, right? So we take a weak subsequence, we make an entry in the difference table, all the dictionaries, but we don't take a part of our total. You see this total, it is in the if condition, correct?
Okay. Yeah.
So this total, and in the total, we are never, in this if conditions, we are never adding. If we go back, now this table is clear, right? Let me clear this. Okay. So if you if you see in this if part, okay, here you are not adding any one. So where you are adding one, only in here, correct, which is outside of this if case, and this if case, outside of the if case, which states that you are adding only one explicit one when it is a weak subsequence. Okay, but when it is strong subsequence, we are assuming that there is a value already added here by the weak subsequence, and now you are going to make it stronger
Yeah.
because you
Makes
are
sense.
already having another element which you can append to the weak subsequence.
Yeah. Typical, I mean, way of filling the like table. Like either we don't have any sequence here to follow, right? Or diagonal or top left or something like that. I mean, it's a
Right.
very randomized way of filling.
Well, it
Not
is a very
randomized.
smart way of implementing, I would say. Yeah, it's not an easy, but this is the way actually they are doing it.
Yeah.
So if we okay, let me actually share one of my C++ code also,
Sure.
because maybe there will be more. I can add slight more confusion to you guys, and also, but okay. So one of the code what I found, and they say this is much better in compared to other implementations of C++ is okay. This is a map they are using. This is map just initialized to the size of an array, and this is a set. And set actually they are pushing all these input array, this A array, into this set. So we can actually look in this set in O of one time. So therefore, actually it adds to the time complexity. It becomes more efficient. So the same way we are running in this IR pointer on the very top loop, and this is a j pointer which is actually going till I only always, and then it calculates the difference each and every time between the I and j. Okay, so that is the difference I'm calculating here, and then just taking care of it's not going to go out of the range. And when I come here, when I find if there is a difference in my map, if I find this difference, initially I won't find, right? So if I don't find, for if we just keep this condition for some time, then what I do is I look back in the set. Okay, what I look back, I take this difference here, okay, and then add it to my AI. AI is the top loop. So I'm trying to find if there is some other element after I, after this current index I, or maybe, yeah, after this current index I, which has this value plus difference. So it means I can form a strong subsequence, right?
Yeah.
Then I'm actually updating my map with that count. Okay. So the count, if initially it's initialized to 0 because I don't find anything in my map, right? So that is what it looks for. If you see this here, it tries to find in the map. If I don't find anything, I will initialize it to 0. If I find something, so whatever those values are, I'm incrementing there, that I'm actually adding to the count. So the way we are looking for that 2, 4, 6, right? So we
Yeah,
had two values in the 6, yeah. So that count will be updated here. And here actually it comes back that count is taken and then it is incremented by 1. If I find a strong subsequence or maybe an additional subsequence, right? So the count represents now both in this case. Initially, it will do a weak subsequence while coming down, okay? But that time it is not going to form it won't be a part of my answer, right? Because
Yeah.
it is in this if cells and it is just directly adding it to my map, not adding to the count. But when I come in the next iteration, when I come here, so that can be a part of my map if it is already present in that difference and it is a part of that value. It is almost the same what you have implemented, but in a different way.
Style.
Yeah,
Yeah.
I don't think so. It's an easy problem, absolutely. But we'll have to go through such problems couple of times, and it might be much better.
Yeah, it will take some time to sing that concept. And concept I sing, but filling the table was a bit uh, not that straightforward.
Yeah, and we also took a risk of exchanging the dimensions.
Yeah, yeah.
Yeah.
That is what we did, but that was easier to represent, right? Yeah.
Exactly.
Okay, let's go with the next one.
Yeah. So next one is like car fleet. So n cars are going to the same destination along one lane road, and the destination is target miles away. Now each of the car will have a constant speed, which is in miles per hour, and initial uh, position I, which towards the target along the road. Okay. I mean the position of initial position of the car from the target. That is, a car will never pass another car ahead of it, but it can catch up to it and drive the bumper to bumper at the same speed. Okay. The distance between two cars is ignored and they are assumed to have the same position. A car fleet is some non-empty set of cars driving at some position and same speed. Note that a single car is also a car fleet. If it catches to a car fleet right at the destination point, it will be considered as one car fleet. And how many cars will arrive? They have asked in this. So it's like, I mean, we have this road, right? Here is our target, and here we have multiple cars. Car one is here, car two is here. They are the initial positions. And there could be two things, right? Let's say the speed of this car is x, the speed of this car is y. So if x is greater than y, then definitely it will try to collide. So whenever it collides, this car will superimpose over this, and the speed of this car and the previous car will be same. So this will become one fleet now, right? I mean, now you have to find that will both the cars reach the destination at the same time. So how many such fleets will be there? That is what you have to say.
Actually, for that arithmetic subsequence question, I found a very straightforward solution.
Uh,
It's I mean, it will take 2 minutes if you guys
okay.
are interested.
You want to share?
Yeah, I can share.
Sure.
So it's on Leetcode. I was just scrolling through and uh,
Yeah, you can share it, no problem.
so they are only like taking a DP array of it's like a list of size A, initializing the sum by 0 initially, and what they are doing is looping through the array once and just
Hey, Dipali,
This is the
this is
sub-array
one.
one.
I think.
oh,
Sub-array one.
Yeah, that's why it was looking very easy.
okay, my bad.
No problem.
And then how sub
It's
array?
actually the first variant of the question where
Yeah, yeah.
we
That's
were
very nice.
taking contiguous sequence for counting the AP part.
Oh, now that we have to skip indexes, it becomes tricky.
Subsequence. Yeah.
Okay, okay, my bad. Thanks. I'll stop it.
No, no, no. Yeah. So, yeah, these are the positions of the car is given and the speed is given, and these are target positions. So we have to find how many such fleet of cars will reach to the target destination.
Yeah. Can you scroll up, Shashank?
Sure, sure, sure.
How
So
is
the
the
idea is same as finding connected components in a graph, but here components are connected if their bumpers are touching each other.
Mhm.
And the bumpers can touch even at the target also. There also we can consider it as a one fleet. I
Yeah.
mean, on the way itself also bumper can touch and bumper can touch at the destination also. So that will also be considered as a fleet. The case like this one, if both the cars are, I mean, here is a target and he also takes 1 second to reach. He also take 1 second to reach. So both of them will reach at the same time. So that will be a one case of lead, and one is like if this x speed and this is y speed and y speed is greater than x, then it can never cross this, right? So it will have to meet somewhere. So this is also one fleet, I mean, on the way. Yeah, yeah, we can go ahead.
Are you going
I didn't
to?
really get this line.
Yeah, I think, yeah, go ahead.
Line, a
Harshit,
car can
Harshit.
never
Mhm.
pass another car ahead of it.
His voice is breaking, or is it my
But
problem?
it can catch up
Even for
to
me, it's
it.
breaking.
Harshit, your voice
So
is
is it not
break.
contradicting?
Okay, he's saying the way you said, Shashank,
Yeah,
the cars cannot meet, they cannot
Yeah,
overtake. So he's saying is that a contradictory statement?
no, no, he's saying, see, if a car can never pass another car but can catch up to, see, in real scenario, it's not possible. It's a hypothetical situation, right? That
Uh-huh.
whenever I mean, if the previous car has a bigger speed compared to the front car,
Hmm.
then definitely the previous one will encompass the front one. But it can't go ahead, and both of them will paste each other. You can say something like
Okay.
superimpose over each other. Yeah.
Mm-hmm.
So now it got superimposed. Now both of them. Now the speed of the second car, I mean the back car will be same as whatever the speed of the first car is. Now both of them will reach to the destination at the same time.
Okay. So when they are actually crossing each other, it means they become one car, a fleet.
Exactly. Yeah. Mhm.
So only the
Or
car behind car speed is very slower than the ahead cars. Then it means that it's not going to be a part of the previous fleet. It's going to be its own fleet.
fleet. Yeah, that is the
Yeah.
I mean crucial point. Yeah.
So any time whenever we have a car with a slower speed, and when we are coming, if we sort it by the speeds, right, and if the highest speed, all the cars, if we take the highest speed and all the cars which are having, oh no, that also can't be a one way, right? Okay. So there may be one car. Okay, if we have all the speeds, we should see that they meet each other also. Okay.
Yeah.
So we cannot sort on the speed. We'll have to sort on the position.
Position and speed both.
Okay.
Um,
Go ahead.
so I'm just seeing the example like that they have given. Uh, just like our target is to reach 12, and we are given the position of the cars and the speed of the cars. Why are we adding it? So they are saying 10 plus 2 and 8 and 4 will reach meet at 12, and the cars 3 and 5 at position 3 and 5 will meet at 6. Even though we add, that still makes it a uh, two cars, right? Two car fleets. So why the answer is 3 still?
You skipped the car 0 or the car starting at 0.
That's 10.
Yeah. No, the zeroth
No,
one. Zeroth car with speed one.
The zero one, the
the
middle
third
one.
one,
Mhm.
third one.
This one. I mean zero.
Yeah, and it has a speed very lower also.
Or like this, you can say if is your destination and if you sort the speed, zero car has one speed, your one car will have three speed, right? And five car will have your one speed, and even eight will have four, and this 10 will have two, right? This I mean I've sorted based on the position and speed. Now, if you calculate this, what do you say? Uh,
Time taken to
this is
reach the target.
time taken here. So this will be your 2, right? 12 minus 10 by the speed of the 10 if you divide. So it will be 2. There's a arrival time, you can say, kind of. Now 8 minus 12 is 4. This is the distance 4, right? No, arrival time you have to divide it by this. What is the speed of 10?
Speed actually. Speed of 10 is 2, speed of 8 is 4.
Okay, yeah, speed of 10 is 2. So this arrival time for this car is 1, right? And this is the distance between this car and 12. So 4 by speed of 8 is what? 4. This is also 1. And next car is what? This 5. 5 minus 12 minus 5 is 7. So this distance will be 7. And 7 by the speed of 5 is what? This will be 7 as it is. And for this is 12 minus 3 is 9, and 9 by 3 will be 3.
Which example have you taken?
12 minus 1, I guess. 12 minus 1 by 3.
This
Be 12 minus 1, I think, right? Also, the previous one should be 12 minus 5. And then 7 by 7, again, it will be a speed of 1.
I made a mistake somewhere.
Oh, you are echoing, maybe. I'll have to stop. Someone will have to stop this.
But my question is why are we adding speed to the position?
Yeah, we are not adding it. We are updating the speed. I think this zeroth car, I'll tell you, zeroth car is distance is what? Distance will be 12 and speed of 0 is how much? 1.
Distance, it's a speed and position.
No. So
Yeah,
zero in itself is a fleet. A single car can also be a fleet.
yeah, exactly. Yeah, that's true. Single car can be a fleet. So like these two
There
can
are
form one fleet, right? Because both of them have the same arrival time. If you trace from this side, they have arrival time of 1, so they'll form one fleet. Now this will reach your destination at what you say it will take 7 unit of time to reach your destination, and this will take 3 units of time to reach the destination. So definitely this will be faster, right? Somewhere it has to meet this. So when it will meet him, so
No,
the whatever the speed of this is, same speed will be given to this, and these two will become one fleet.
Well, don't clutter with many of those diagrams. It becomes very difficult to follow.
Yeah, what
Yeah.
to do?
Okay. So now I lost somewhere, when you started with the sorting of the per
Let's
position,
do it.
right?
Shall I make it fresh? Then
I no, that may be okay.
we can make it fresh.
So okay, so if we first what we are planning, we want to sort it on position. Is that what you're
Position,
trying to?
position and speed I'm sorting. Like this will be
Maybe not
priority.
at speed, maybe position and time, how long it will take to reach a target. Yeah.
Yeah, I'm sorting it on the based on the speed, like speed corresponding with its position. So this is 8-2 and this will be your 10-2. Sorry, 8-4 and 10-2. Right.
No, no, hang on. So what is 0? It's the
0
position.
is the initial position and its speed is 1. So I've sorted it based on position and speed. Position is first factor and then speed
Okay,
followed by speed.
cool.
Now I'm
Position is
drawing
first. Cool.
this diagram. This is your
Yeah.
destination. This
Yeah,
is 12. Okay.
does it mean that we can have two cars which is started at same position because you are sorting by two parameters? Yeah, it means that you want to sort even when car have the same position.
Yeah, if the position is same, then we'll go for the speed. Whose speed is better?
Yeah, you might have two cars starting at the same position. You never know because
But
that's
that will
not
not.
mentioned.
So in
Yeah.
that case, is it not like boils down to like just adding these numbers and whichever are duplicates will be in the same fleet?
I think that is what he's trying to do.
Okay, let's complete it. We'll go there then. So this, I'm just marking same thing, whatever in a diagram, then it will be better. So this is your speed of this car is 2 and initial position is 10, right? And
Mm-hmm.
here, this is 4. This is, I mean, 8 is the position and 4 is the speed. And for this car, 5 is the position and 1 is the speed. And for this, 3 is the position and 3 is the speed. And this is 0. 0 car has a speed of 1. Now 10 will, if 10 has to reach to 2, it distance is 2, right? And 2 by its speed you divide. So it will take arrival time for this is 1, right?
Okay,
Okay.
I mean,
a second.
now
I have a question.
go ahead.
Why are you calling speed as distance?
That might, I mean,
Okay, I thought you are doing it, saying it purpose because
no, it might be a mistake, I mean, while speaking.
okay, cool.
So like 12 minus 8, that is 4. And 4 by 4, if you do, so arrival time is 1. Now 12 minus 5 is 7. 7 by 1 will be 7. And 12 minus 3 is 9. 9 by 3. 9 by 3 is 3. So arrival time is 3. And 12 minus 0 is 12. By 1, you will make it as a 12. Now, if we go from this side, if you traverse the timing, what you are saying, the timing of these two cars are same. So both of them will reach to the destination at the same time. So this is one fleet. This one.
What subtraction did you make? 12 minus what?
12
12 minus
minus
He's
position.
doing distance by speed.
distance by speed. Time is equal to distance by speed. Difference of distance by the speed.
Difference of the
Haven't been given, oh, distance is 12, is it?
yeah, that is the target is
Yeah.
what we have to
Target.
reach.
Yeah.
So that is what if you say it's miles, okay, and then the first one which is at 10 position, that is a car which will reach in 1 unit of time.
Time. Yeah.
Yeah.
Like,
Because if you do 12 minus 10, which will be 2, and if you divide the speed, which is also 2, 2 by 2 will be 1. So 1 unit of time. So all the cards are assumed to start at the same time, right? So
Yeah.
therefore, he's saying that if all the cars whose arrival times or the unit of times are the same, they will form a single fleet. Okay,
Yeah.
and if they are different, but if they are
Now
crossing each other, right?
this one exactly. Since the speed of this previous car, I mean, if you are at current position I, you check I minus 1 speed. So I minus 1 speed is lesser than not speed, sorry, timing. I'm saying the timing of 3. It will reach the destination in 3 time unit of time, and it will reach in 5 unit of time. So definitely this will cross this bigger car. I mean, front
Okay.
car, right?
Okay, so what you are trying to say here is the car which is at this third index, which is the time is unit of time is 7, right? And the
Yeah.
previous car unit of time is 3, which is actually lesser, so that will be a faster car than the previous one. So they both will actually clash together and combine as a single fleet, correct?
So this is one fleet.
Okay.
Yeah, so you can prove this also, right? So if we use the equation of motion,
Okay.
so for 5, it would be S is what? Ut plus half at square, right? So A is 0 here. So for 5, it would be initial offset plus
Time.
ut. So u is 1, right? The initial speed.
Yeah.
Okay, so it becomes 5 plus t.
5t. Yeah. Oh, sorry, 5 plus t.
No, yeah, 5 is the initial one, and then u is 1. So 1 into t is t. So 5 plus t.
What are you trying to explain? I'm not following.
I
So
mean,
I'm
he's
just trying to show that these two
Speed
cars will
formula.
meet.
Yeah.
he's maintaining just ut
Yeah.
plus half it. Whether normal basic equation we do it.
Not half
Yeah,
at
so
square ut plus v80, right? Or v is equal to u plus 80. Yeah.
Yeah, this is another.
no,
I
no,
mean, here
not
acceleration
v.
we don't.
I'm doing s equals to s naught
U.
plus ut. Let's forget a because there's no acceleration
What
here.
is u here?
Initial
initial-
velocity.
Velocity. Yeah.
Okay, but to make it very simpler, so the car which is preceding or in the next position or I minus 1th position of the current car, and if that speed is higher, it means if the time to reach, the unit of time is lesser, then we can straight away say that they will meet each other, right?
Faster. Yeah. But again,
Correct.
one problem is like both of them are a different distance, right? So it's
Oh,
again.
so no. See, the unit of time you are calculating based on your position also, right? And also on the speed. So the unit of the time is the best way to compare because all of them are on the same benchmark now or the baseline.
How
That is
will
what
you say
you started with, right? So you started with 12 as a target, and then you are actually subtracting 3. That the position or the it was
Okay.
3, right? 12 minus 3 was 9. 9 divided by 3 is 3. So it's going to take, so that is what I said. All the cars which even though are at very different distances and different positions, they start at exactly the same time. Okay. And therefore, and if you just calculate the way and the time they are going to take to reach, assuming that there are no cars ahead of them, if everyone is allowed to go at its own speed, so then they are going to take that much time, right? And whenever we see cars with the same timing, so you can actually combine that is one way to combine. And second way to combine is the 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 previous time and the next time. Okay, if the next time of the car is smaller, then you can combine.
No, yeah, that's true. That shows that previous car is faster than
Yeah.
the hired car.
So you can do that within O of n time, the linear time, right?
Okay, yeah. So what reason will you give for this? You said I mean I missed some that. I mean, although they are a different distance, but still.
Yeah, because when you are actually calculating the time, so the time is what you are calculating based on the position as well as the speed. And all of them are starting at the same time, right?
Yeah.
So whatever the time, if you say 1, okay, so this car will reach whatever the position it will reach target in 1 hour. The car which is at position 8 also will reach the target 12 in 1 hour.
Yeah.
Right. So the car which is at position 8 is actually faster than the car which is at a position 10, right? If you look at the speed also. And so
No,
the
they're the
same,
same. Yeah, yes, they're faster, right? Right.
yeah. So therefore, if we just forget about the speed and the positions, and then we are actually now why we came to this part that we are actually calculating the time per unit time. So to compare them on a same baseline, right? Because the positions are different, the speeds are different. So we need some way to compare them.
Kind
So
of a
this is what
ratio.
the best way to compare, right? The time is the best way to compare. And that is what you did, correct, Shashank?
Yeah, but I couldn't draw that inference. I mean,
No, that is what
mathematically,
it is.
like t is equal to d by s. Yeah.
That is what
Yeah, so
exactly you did, right? Uh-huh.
the two things, right? So they can be a fleet. Either it is an individual car, like it is for the case of car 0,
Last
right?
one, yeah.
Or they meet at the destination at the same time, which is the case for car 8 and 10, or if they meet somewhere in between.
On the highway itself, yeah.
Correct. Yeah. Hmm.
Yeah. So 3 cases, right?
Yeah, three cases. Yeah. So the first case will be the way you said, they meet at the destination, which the times are same. And the second is the second block, what is showing for 7 and 3. And the third is the 12, which is completely diverging from the other two fleets.
Plates, yeah.
Yeah. So can this be done in O of n? I think someone said it.
Yeah.
Yeah, open it can be done. You
So
just
because
travel.
if you just calculate this, the what we did, that unit of time, then you just have to traverse the array again for this unit
No,
of time.
but actually we cannot surpass a vehicle, so we need to sort it with positions at first.
Yeah, that
Sorting.
that is n log n. Yeah, we'll have to do a sorting. So he did the sorting already, right? After sorting, you can do with O of n. Yeah, sorting is
Yeah, that
required.
is
Yeah,
simple iteration. Yeah.
yeah.
Okay.
After sorting, we
So
can
you
just
sort.
iterate over the
He did the
time
sorting,
length.
right? So I'm just assuming that the sorting is already done.
Okay. So you sort first, and then you start from the backwards. Is it?
Exactly. Yeah.
Yeah.
Or you can use a stack directly and just stack. No, I mean what? Yeah, backwards also you can.
So it's
Okay. So let
Yeah,
me
sorting based
just
on
go through it,
position.
right?
Yeah. Hmm.
yeah,
So
we
for
can
10,
use
you
a
find the
stack
time
and
as
then
1.
Yeah, yeah, yeah. So I
Okay.
and I
So
minus one you check.
okay, you check only I and I minus 1.
Yeah, I mean two cars you take like this.
Okay.
Otherwise, I mean two adjacent index we are taking, and then depending on if they are money, let's say third car was also at one only. So when you merge these two, your I will be here. Then you check this I and this I. If they are, then again this will form a fleet between one fleet.
Okay.
Yeah.
Yeah,
I'll show you code.
we can check just one car as well. Just image that we at first car, yeah, when 10 is just 1 hour, yeah. Okay, we now we are collecting how we are collecting batch for 1 hour, and we traverse from the right to left. Okay, 1 hour, this one batch, yeah. Then we meet and 7 hour, yeah, car which will take 7 hours to reach finish, yeah. It's the next batch, and three less than 7. So keep this car in this batch and traverse to next car. It's 12 12 hour. It's next batch. So we have 3 batch here, and we cannot to look at adjusted car. We can just look for one car and traverse through the n-1 till the 0. Yeah.
From
But
backwards.
will not that be n square, Nick? Because when you uh, stop at one car, you're saying that you are looking to make a batch for 1 when you are at 10, right?
No,
So
no,
you
no,
will go
no.
all the way.
No, just from car by car. We are looking for at the last car. Yeah, time is 1 hour. Yeah, we update our current maximum time, which we need to reach a finish. Yeah,
Okay,
it's
okay, got it.
it's one. Okay, we check another car. Eight has one. Okay, same batch. Next car 7. Oh, it will take 7 hours. It's bigger than our previous maximum. Yeah. So it's this next batch 7 3. Okay, 3 will stack to 7 kk. Yeah, and then we check.
So you are taking your maximum of pairs is taking and just checking with the previous one, like whether it
Yeah,
is.
yeah. We just need to calculate new maximum. Yeah, and check.
Oh yeah, if you calculate the new maximum always, and
Yeah,
whenever there is an increase in the max, you just keep on incrementing your answer count, right?
Yeah, yeah.
exactly.
Wow. Okay. Yeah, that's a very smart way of doing it. Or I
That's
was
actually
thinking
the
like put into a
optimized
bucket.
way of the stack approach, where
Right.
when we start moving from the right end, we can just push the current time needed in the stack if it is empty, and if it is not empty, we will first compare to the top of the stack. If the time at the top of the stack is greater, uh, if it is greater than I guess uh,
At the top of the stack, if it is okay, whatever the time is lower
yeah,
on the top, yeah,
if
then
it
we
is
don't.
lower, then we don't have to push it. If it is greater, then we know that the current vehicle will take much higher time than that of the previous fleet. So this will be a part of the new fleet. So we will push this in the top of the stack again, and at last we can return the final length of the stack.
Right.
Hmm.
So you're saying in this example, what you said, sorry, Shashank, I'll just write here. So
Yeah,
you
no problem.
first push one, correct? So the
Yeah,
second is also one you're not going to push. Then
one,
the third one is seven, but seven is greater
seven.
than one, so you push, right?
Yeah,
So, but when three comes, the three is smaller than the top of the stack, you don't push, correct? Then
yeah,
you come with 12.
yeah,
The 12 is greater than 7, then you push 12. And then
yeah.
this is
Monotonic.
your answer.
Yeah.
Yeah,
And then
maybe.
we return the length of the stack.
Yeah,
Stack. Yeah.
return the length of the stack. Yeah, that is a good
But
way.
to optimize this, we just need the previous max current time.
Correct. Yeah, just a single count should work. Yeah, absolutely.
Yeah, yeah,
Cool.
So this is
So we
what
have a
like
solution now, right? Yeah.
same thing like what Abhishek is mentioning. I mean, so you are just sorting it and going from the back, and for every car position and speed you are taking, calculate the arrival time. And if you find, I mean, if the stack is not empty and the arrival time is greater than the top of the stack, you just push it into the stack, right?
Yeah.
And at last just return the length of the stack.
And Nick was saying that instead of using a stack, you use just one variable and then you
Max.
keep on counting the max so far. Yeah, that is a good way of doing it, right? Yeah.
Yeah, that will save the space.
Hmm.
Yeah,
Yeah,
but
Abhishek.
Shashank,
Yeah.
if you have it equal, then where are you updating the answer? If your arrival
no,
time
but
is equal.
if it is equal,
Mhm.
then we know that it will reach the target at same
So
instant.
Yeah,
So it
just
will be
deliver.
part of the same fleet.
ex-
So it will be part of the
O-
same fleet.
Okay, okay. So, okay, got it.
So even if
already
we
one
include the first one, that's fine, right? Yeah. Mhm.
already we
Yeah,
have one that one, right? So even if you include one,
yeah, yeah.
it's
Got it, got
yeah.
it.
You
Okay.
you want to share something?
Yeah, shall I share my approach?
Yeah.
Yeah, yeah.
Okay. So, so this is the first one where first I am making a vector of pairs, and in the vector first I am assigning the position and the time taken to reach the target is the second one. And then I am sorting it, and this comparator function is just reversing it back. And then I've assigned this answer variable and the current time. And when I am iterating through the vector, I will check if the current time, if it is greater than the previous time, then I will increment the count and then update the time and then return the final answer. So this was the optimized one of the stack based approach.
Without space, you're doing.
Okay. So you are actually okay. Yeah, you are just using answer. And I is okay. Yeah, you
And
are taking from that
we,
vector, right? Okay. Mhm.
yeah, and just we need to check for the double one, since in Python it already checks it beforehand, but in C++, if you
Mm.
directly divide it, this will come as an integer.
Mm.
So you
Very
need
good.
to typecast it to double.
Yeah.
So are you iterating from front or back?
Uh, I have first
Fine.
sorted it and then reversed it. So I am iterating from the front only. But
Oh, you
okay,
have
so I first
sorted
sorted it and then I reversed it. So it is
Same thing.
it is iterating from left to right, but the idea is just same.
ascending order. That means whatever you have
Yeah,
sorted.
yeah. And then here it is mentioned that the initial positions are different. So we can use this fact to again optimize this approach. Here, since we are using pair of int and double, uh, so it is taking, I guess, 2 into n space. So for this one, we can skip this part and use a map here. which will be into double. So in this one, I have just calculated the time, and then I have pushed in the map. And since I need the map in reverse manner, so I have pushed the key value is negative of the current index. So here I guess -10 will come first, and even when I have to iterate, -10 has to come first in the first approach as well. So this part is just same. In the first part, I have just used the fact that all the positions are unique. All the
Oh,
initial
okay.
positions are unique.
Mm-hmm.
So what
So
advantage you are getting?
advantage is
Uh,
implementation advantage, right?
yeah,
Because map is still going to be a log and operation, so n log n there.
yeah,
Yeah.
yeah. In average case, it will be log n, and in best case, it will be constant time, I guess.
Mm,
Not always, but
hmm.
we can take the average one. So
Yeah,
it
so
will
we'll
be
have to
in
take as per the of n, yeah.
n,
What is that
and this one
minus
will be log n.
position? What is
Minus
that
of
minus?
position is actually doing it the reverse way. So the way you do
Oh,
in
that.
Python, yeah.
So
Awesome.
same
Hmm.
in when I was sorting it, I had to reverse it back. So in map, otherwise I had to iterate in the map from the reverse beginning. So it will be from the end of the map. So to save that time, I just pushed the key as negative of the index.
Oh, if we
Yeah,
enter the numbers as a key, it is ordered. Is it?
yeah, yeah. It is already sorted in the order of the key.
But are you sorting it specifically or
So
it's a
this is ordered
No,
map, so it will always sort.
so yeah, the map sorts it and then pushes it back in the map.
Good. Yeah, so this is very easy in implementation, right? Yeah,
Yeah,
that makes sense. Instead of having another comparator and all that, yeah. Cool. Okay.
yeah.
Yeah.
Yeah, then we can
Thank
move to
you.
next.
And then we go to the last one.
Yeah. So yeah, last one is like you have to find elements in a contaminated binary tree.
Mm-hmm.
And binary tree with certain rules are there. Root dot val is 0, and if your root dot val equal to x, then and if your left node is not equal to null, then the left value will be like 2x plus 1. I mean, like the normal tree representation, left tree and right tree will be 2x plus 2. Now binary tree is contaminated, which means all the tree node dot val has been changed to -1. You need to first recover the binary tree and then implement the find elements class. So what it will do, root node will be passed, which will initialize the object with contaminated tree, which you need to recover it first. And we'll have a Boolean function which returns if the target value exists in your recovery tree. Okay.
So the second
So
one is just searching for the key in the tree, and the first one is, I guess, traversing the entire tree and then assigning each of the individual values.
yeah.
Oh, but you
So
Sorry,
can
what?
do it on the fly also, right? Whenever you try to find, you can keep on updating the values. You don't have to update the values all upfront.
yeah,
Yeah,
on
we
the
can just iterate through all the nodes of the tree and then keep assigning the values using the same formula which was given in the question.
Yeah. Yeah. Sorry, Harshit. Go ahead first.
Yeah,
No,
so
it's okay.
yeah, go ahead.
Jeff and
No,
Abhishek.
go on.
Well, yeah. So what Abhishek you're saying, if you do everything in the find elements, which is a constructor, correct? So if you are
Yeah,
building that, so you are doing it. And in case if we don't uh, try to find all the targets, if it's a very sparse finding, right? So in that case, you are consuming more time.
Space, yeah.
so but we don't know at first if the value exists or not in the for the find function. So first we need to recover the tree. That means we have to iterate through the entire nodes of the tree.
Right. So,
So
but that you
first
can
is
do it during find also, right?
yeah, but in the question it is mentioned first we have to recover the tree and then we will implement the find function.
You need to first recover the binary tree and then implement the find
Find
element
element
class.
class.
But they are not saying that you have to do that in the find elements.
Yeah.
They are just saying that is the core intent of it, but you can do anywhere. It's not specifically to be done. Yeah, but yeah, that way also works. But okay, yeah, let's go that way then first.
Okay, so for this first when in the constructor when the root node was passed,
Hmm.
uh, it is mentioned that the root of the tree must have the value 0. So I made a again build function which will build the entire tree while iterating through all the nodes.
Okay.
And the first value is 0 since we know that the root of the tree to be has to get the value 0.
Hmm.
So in the build function, these two are the parameters. One is the root node and the value. So
Hmm.
if we go to the leaf, we need to return back. And if it is not leaf, we have to assign the value first.
Hmm.
Uh, let's skip the seventh line. And then for the left and the right part of the tree, it is mentioned that the if the left part exists,
Hmm.
the left part value will get the value 2 into current value plus 1, and
Hmm.
the right one, if it exists, it will get 2 into current value plus 2. So this is just a recursive call and this will recover the entire tree.
Hmm.
Now for the search function or the find function, since it is not mentioned that since when you construct the tree, it will be a random binary tree, I guess, not a binary search tree. So if if we search the entire tree, then again it will take off n time since we need to go to each of the nodes. So
Hmm.
this is why when I was building the tree, I used the unordered set and pushed all the values of the tree inside the set. And then for the search function, I just have to search if the target exists in the tree or not.
Right. Yeah. Then that becomes easier to return. Yeah.
Yeah, otherwise, again, we need to iterate through all the nodes of the tree.
Yeah. Yeah. But in that case, if we just twist and says, okay, you don't build it initially, then you start from whenever you are actually in the find, you start and find it. So that also might be one way of doing it, right? Yeah. But if you're saying we do it initially, then yeah, this is the best way to do.
Okay, so are you saying that you check for root dot val, uh, like 2 into root dot val plus 1 or plus 2 in the left and right calls
Correct. Yeah.
that way?
Yeah. So usually whenever you have the iterator function implemented, right, you don't actually do everything, construct the whole tree iterator first. You actually
Mhm.
keep on doing it when you go to the next one always. So that you save some space and some time. So yeah, but this is as they're explicitly saying, then this makes more sense to do this way. But if when we did this and the interviewer finds, yeah, this is easier for him to do, then what next? So then if he twists and says, okay, I don't want to do you to completely build it initially, then you start building in the find. So in that case, how you will do?
I mean, the
Okay,
way you
so
told. Mm.
Right. So what we can do in the
so
target, so whatever the value we have, so the way we do for our heap, right? So for the heap, whatever we at position we are, we multiply by 2 and plus 1 or plus 2 will be the left and right position, what he has been doing for the on line 8 and 9. So in the same case, you take the target, you divide by 2, right? But if the target is itself odd, then you know that it's going to be a child of a left subtree, right? Then you divide it by 2, so then you go to its parent, and then you find what the parent value is. If it's not odd, then if it's even, then you know that it's going to be another, its parent is going to be, this is going to be a right subtree of its parent. So and so forth, you keep on going up the tree, and then when you reach finally to 0, okay, then you know whether you really have some value in it or not. And then you'll have actually have to form some sort of a stack or something, and then you keep on coming down that, uh, using the stack or in any array or so. Then you keep going in the tree and find if there are uh, nodes present at those particular subtree, because that is what the thing is, right? We have to find if there are valid.
I think the odd even case is not feasible, since if here, if we go to the right index, no, if the target value is, let's suppose it is odd, then we will see that the we can achieve the odd one in the left part, right?
Hmm.
Uh, but this may happen that the left part of the right value is also an odd value, since it will be
Then it will be left, right? Well, let me share my implementation.
I have a question,
yeah,
Santosh.
sure.
So where you mentioned we start iterating from in between and keep going up the tree and find in the right or left parent based on whether it is even or odd and what is our root value. But how do we determine the starting position of iteration? Because we
Yeah,
are given
because we
find,
have to reach the root, right?
but
So
where to?
root is always 0. So because that is what our starting point is, right? So the root will always be 0. Okay. So see, in the heap also, if we can go from any root to any of its children's, right, left or right. The same way, from any children you can still go to this parent. That at least that concept is clear, right?
Yeah, but why are
Yeah,
I'm trying to understand the problem statement only. See, we are doing this if we are asked not to build the tree beforehand, but find the elements while building the tree or something like that.
Hmm.
Are you saying that we are starting the iteration from any random node in between and going?
Right, right. I'm trying to do that way. Yeah. But then in that case, if we are given a target which is not a present in any of the node, there is no node present, right? So then you can make out, right?
Hmm.
So, but first you assume that there is everything, and based on that you find what is the your target is a part of which subtree, right or left, and keep on building that. Okay. So what I'm trying to do first is I'm trying to use a stack.
Okay.
Okay, and this stack is this whatever it is. So then this is my target value. Okay, I look for if the target value is even. Okay, so if it's even, then I'm just subtracting -2 from it. Okay, and then I'm pushing the value as 2 to represent that 2 is for a right. Okay, if it is not, then I'm actually subtracting 1, and then I'm pushing 1. So 1 represents left and 2 represents right, and then keep on dividing the target by 2.
But why are we subtracting from target?
Yeah, because we actually add this one, right? If it's a left subtree, we add 1. Okay, and the right subtree we add 2. Okay, so that is what the binary heap will be. If you want to actually store a binary heap in an array, right? So every time if you want to see the binary heaps left and right subtrees, you'll have to multiply it by 2, the value index of that, and then add 1 or 2 to reach to its left and right subtrees, right? So when you are done with the stack, okay, so you start with your head again. Okay, and then you start actually going through the stack again, and then so now this traversing is only height of the tree always. It's not going to be the whole of tree, right? So we
yeah.
are not going to the traverse the whole tree. So even if the code looks big, but it's going to be just the height of the tree. So you just go through the whole stack again and then keep on popping. And whenever you see if it's 1, so you know that it's going to be left subtree. So you just move to the left side. Okay. And if you don't find anything, you return false immediately. Or if you find, then you go to the right. In the case if t is equal to 2, then you could go to the right. And if you don't find right at that position, then you return false. And if you are able to actually successfully uh, pop up everything from the stack, then you return true. Okay, this is one way of doing, but I'm not sure whether this might be as per the. I actually saw this one over here now when he's saying that you have to implement before, you know. So, but what Abhishek did also should be fine as per the scope of the
Yeah.
statement. If in
Otherwise,
case, yeah.
I actually
each
have
time,
a question.
Yeah, can we run through an example
otherwise,
just to get this more clear?
How
Okay.
the stack
So
is
otherwise each time
let
when
it
we
take
are
14. 11. Okay. Yeah. Sorry. What was the question?
So, so let me actually visualize so that you can visualize it. So this is your root node, which you know that it's always 0.
Mm-hmm.
And your left will be
example
2x,
I'm taking.
2 into x, 2
Okay.
into x plus 1. And that will be 2x plus 2.
Okay.
Yeah. So this is what Santosh is doing here. So you are given that, and then here you have node, and then you have some values here, right? So you are given some value here, right? This is the value you are given here, the target. So when you are at your target,
Go ahead, go ahead.
so here you are checking that. So you know that this is, so this will be at index 0, 1, 2, 3, 4, 5, 6, right? So you are checking that whether you are at the even position or odd position. So for even position, you know that to go to the odd position, you have to do 2x plus 1. And for even position, you have to do 2x plus 2. So that's why if you are at the even position, he's subtracting minus 2 to reverse that. And if you are at the odd position, he's subtracting minus 1.
Okay. It's to traverse to the root. Okay.
Yes. And then divide it to get the parent. So all the way you will go up to the root.
Okay. Okay.
Mhm.
Yeah, but why are we doing it? I mean, why are we storing it in a stack? We are using it in the following traversal, right?
Yeah, so now you are storing in the stack because now you have to start from here, right? So you have at the top of the stack you have the root, and now he's
Got it.
traversing back to from root to the node.
Mhm. Yeah, yeah,
Yeah.
makes sense.
So one thing, in Geeks for Geeks, there is a very good implementation of min heap. Okay, it's a complete implementation.
So in
Okay,
your
if you go through that, you'll really understand it, the heapify and all those functions. They are really clearly mentioned, and all these things are actually there too. Yeah, sorry, go ahead, Dipari. What was your question?
so in your code, you haven't recovered the tree. Without recovering the tree, you are trying to find the nodes.
Correct.
Okay, okay.
Yeah.
That's why you are finding the position of it and then traversing back to
Yeah.
see all the nodes exist in between.
Yeah.
Okay.
Yeah, and stack is helping us in recovering the path
Yeah.
from the root.
Yeah. So you first find the path and then actually go through the root tree again. And then if you at some point of time you don't find any root, any left or right tree, then you return false from that, or at the end you reach, that. So that would be the
Can you show that recursion? Yeah. So we are just checking whether that node exists at that point.
right.
But
Right.
you have the path.
Yeah.
Okay.
Okay, so if t is equal to 1, then it necessarily has to be on the left,
Yes.
right?
Yeah.
Mhm.
That is
Okay.
what I'm pushing here. So I can push any value, but I'm just pushing 1 and 2.
Okay. And where is the true case?
When you come out of this while loop, so you have successfully gone
When
through each and every whole path.
okay,
Yeah.
okay, cool, cool.
Okay.
Yeah.
Yeah, good to know actually, even though it's a different way.
Yeah, but if you look at that binary heap implementation, so in Geeks for Weeks, they have completely implemented the binary heap. There are many things. I just took a part of it, but that's a very good implementation because we usually use priority queue. We really don't focus on all that detailed stuff, right? But it can be useful many places.
What what I mean, what are you talking about? Can you share it?
Yeah, sure. I can share you the link too. Okay,
Binary heap.
binary. Let me share here itself.
So heap is binary only. Why do we say binary heap?
Heap implementation.
No, we have more kind of heaps.
Yeah, there are
Okay,
tons
okay.
of things, but I like the
You
way
can have
we
multi-children also, multi-children heap.
correct.
An array kind of, right? Okay.
Hmm.
And what I like more about this, if you because we use priority queue and we take all those functions for granted. So in some case, if we have to implement this whole, there are so much of things. See, this is what the get min I, the extract min, and those functions are very
Yeah.
nice, neatly implemented here, and they are all stack
Yeah,
based.
this
Yeah,
this yeah, this function is I guess discussed in the CLRS book. So they
okay,
have
yeah,
taken the idea from there.
right. Yeah, these are
Yeah, and they
very,
also have beautifully, yeah, proved the building heap
yes,
complexity, which is
The
O of n.
harmonic progression, which is.
yeah,
Yeah.
especially the EP5 and all that. But also one thing, this is all stack-based implementation. So if we can imagine how it could be done using a dynamic allocation, memory allocation. So that is slightly difficult. It's not an easy to come up with, and I haven't seen anywhere. But